In this example, we asked to use the laws of logarithms to solve the equation 3 log 8 2 plus log 8 of 7 minus x in between brackets equal 2 plus log of 8 of x, and we need to solve this expression using logs. So we start by we're starting with 3 log 8 of 2 plus log 8 of 7 minus x equal 2 plus log of 8 of x. So the first step in this scenario, we attempt to simplify the first log. So because it's 3 outside, so that becomes the power. So we'd have log of 8 of 2 to the power of 3 plus log of 8 of 7 minus x equal. And we have also log of x, which is also has a base of 8. So we move that also to the left hand side. So we have minus log 8 of x equal 2. So now we can see that we can simplify some of these logs on the left hand side. So that will give us log of 8 to the 8, which will, and also we have log of 7 minus 8 minus x over log of x. So we can put this all in between brackets because they are taken away from each other, so they can be divided by each other, equal 2. And we know that log of 8 to 8, that will be equivalent to 1 plus log of 8 of 7 minus x over x equal 2. So the next step will be moving the 2 to the other side, so that will take 1 away from it. So that will give us log base of 8 7 minus x over x equal when 2 is taken away from 1, so we have 2 take away 1, and that would give us log of 8 being 7 minus x over x equal 1. So that will simplify when we have log of 8 on one side and we take the log of the other side. So that will give us, because we know log of 1 can be changed to 8 to the power 1, so that will give us 8 equal 7 minus x, because we took the logs of both, the 8th log of both sides, so we eliminated the logs from both sides. So we can say divide by the 8th log, so that will disappear from both sides, and we would have 8 here, and we would have over x take away x. Now we're attempting to simplify this, so that would be 8x equal 7 minus x. And now for us to simplify this expression, we simply have 9x equal 7, and that will give us the x value being 7 over 9. And this will be our answer for part A. Or part I. For part I, using algebra, find in terms of logarithms the exact value of y for which 3 to the power 2y plus 3 to the power y plus 1 equal 10. So we're given the expression of 3 to the power 2y plus 3y plus 1 equal 10. So in this scenario, we will try to separate some of the parts. So we have, first of all, have 3 to the 2y plus 3y, that will be multiplied by, so we changed the 1 to 3 to the power 1, and then we move the 10 to the left hand side, so that would be minus 10 equal 0. So the next step, that would give us 3 to the y, and that will give us also, we can assign a factor to it, so it makes it easier for us to work with. So we say, let's say let 3y equivalent to k. So then that we sub k instead of the 3y, so that will give us k squared plus k 3k minus 10 equal 0. So now we can complete the square for this expression. So that would be k plus 5 and also k minus 2. So in this scenario, we'd have either k plus 5 equals 0. So that means k equal minus 5, or k minus 2 equals 0. So that means k will equal 2. So now if we are subbing into the values, so that means we will have in this scenario then sub 3y into k. So that will give us, for the first one, we would have 3y equal minus 5. So in this scenario, we will take the log of both sides. So we would have a log of 3y, and we would also have a log of minus 5. So that will give us, in this scenario, because it's a negative, not valid, we will say it's a not valid solution, as a to the k is bigger than 0 for all x values. So that will be for the first value. Now we also sub 3y equal 2. So now we will also take the log of both sides. So in this scenario, so I'll just separate this. So we would have 3y equal 2, and that will give us log of 3y equal log of 2. So now when we move, the next step will be y log of 3 equal log of 2, and that will give us y being equal to log of 2 over log of 3, and this will be our answer for finding the exact value of y for this part of the question. And this will be also our explanation in terms of why the second log was not valid, in terms of not being positive for all values of x.